Hello viewers, in today's class we are going to discuss one very important and conceptual integral from definite integration involving the absolute value function, right? So here we have to find the value of this integral which is from 0 to half, and here the integrand is the sum of three absolute value functions, right? So here the integrand is mod of x minus 1 plus mod of x plus 2 plus mod of x minus 3, right? So in this lecture, we'll see the area represented by this curve, and we'll also see the graphical representation of this integral, right? Now let us first assume that f of x is equal to mod of x minus 1. Then we have mod of x plus 2 plus mod of x minus 3, right? So here I will assume this integrand as f of x, right? So now let us take this integral as I. So I can be written as 0 to half, and here we have f of x and dx, right? So now first of all, what we will do, we'll try to write this function f of x as a linear function, right? So what we will do, we'll try to write this function, that is mod of x minus 1 plus mod of x plus 2 plus mod of x minus 3 as a linear function, and we'll redefine this function f of x, right? So for redefining this function f of x, we'll make use of the definition of mod function, right? So the definition of mod function goes like this. Mod of x is defined as positive x whenever x is greater than 0, right? And mod of x is equal to 0 whenever x is equal to 0, and mod of x is equal to negative of x whenever x is less than 0, right? So now what we will do, will separately apply this definition to these three terms, right? So now here the limits of integration are from 0 to half, right? So we have this interval, that is x belongs to the interval 0 to half. That is we have to integrate this function from 0 to half, right? So now we'll define this function f of x in this interval, that is 0 to half, right? So let us take these three terms one by 1. So now let us first take mod of x minus 1, right? So mod of x minus 1 is equal to negative of x minus 1 whenever x minus 1 is less than 0, right? So now we have written this statement due to this definition. Mod of x is equal to negative of x when x is less than 0. So here mod of x minus 1 is equal to negative of x minus 1 when x minus 1 is less than 0. So it implies that x is less than 1, right? And see, here we have x belonging to 0 to half. So all the values of x which belongs to this interval, that is 0 to half, mod of x minus 1 must be equal to negative of x minus 1, right? So we can now write minus x plus 1, right? Okay, so now let us take a mod of x plus 2. So mod of x plus 2 is simply equal to positive x plus 2 when x plus 2 is greater than 0. So here we have used this definition because see, when x plus 2 is greater than 0, x is greater than minus 2, and in this interval when x belongs to 0 to half, all the x belonging to this interval are greater than minus 2, right? So now let us take the third one. So here we have mod of x minus 3, right? So mod of x minus 3 is equal to negative of x minus 3 whenever x minus 3 is less than 0. It implies that x is less than 3, right? So again, if we take any value of x which belongs to 0 to half, then that value is less than 3, right? So we can take mod of x minus 3 is equal to negative of x minus 3, that is minus x plus 3, right? So this is how we have defined these three mod terms, right? So see, in the first term, we have this inequality, that is x less than 1. And obviously, all the values of x which belongs to 0 to half are less than 1. That's why we have written mod of x minus 1 is equal to negative of x minus 1, right? Similarly, here mod of x plus 2 is equal to plus x plus 2 whenever x is greater than minus half. So all the values of x which belongs to this interval are greater than minus 2, right? Because here we have all the positive values, and all positive values are greater than minus 2. That's why we have written mod of x plus 2 is equal to positive of x plus 2, right? And similarly, in the third one, we have mod of x minus 3 is equal to negative of x minus 3. It implies that x minus 3 is less than 0, so x is less than 3, right? And obviously all the x which belongs to 0 to half, they are all less than 3. That's why we have retained to these definitions, right? So now what we will do, we'll write f of x is equal to see, mod of x minus 1 is equal to negative of x plus 1, right? And mod of x plus 2 remains the same. So here we have x plus 2. And here mod of x minus 3 is equal to a negative of x plus 3, right? So now these terms have reduced to these terms, right? So now we can simplify this expression. So we have this x and this x get cancelled. So 2 plus 1 is 3. 3 plus 3 is 6. So we have minus x plus 6, right? So now we have obtained this redefined form of the function f of x, right? So now f of x is minus x plus 6 in the interval when x belongs to 0 to half, right? So viewers, this is the most important step of this problem, right? So f of x is equal to negative of x plus 6, right? So now this integral I can be written as 0 to half, and here we have for f of x, now we can write minus x plus 6 and dx. So now we have a very simple integral, and we can now have the integral of x, that is x square over 2, and integral 6 dx is simply 6 of x, and limits are from 0 to half, right? So now we can simply substitute the limits and we'll take the difference. So the first one is half square, so here we have 1 by 4, and here we have 6 times half, and then we have here when we take 0 here, then this term becomes 0 square over 2, and this is 6 times 0, right? So this is negative of 1 over 8, and this is 3. So this is minus 1 plus 24, and here we have 8. So this is 23 over 8, right? So viewers, this is how we have obtained the value of this integral I as 23 over 8, right? So the area under this curve is given by 23 over 8 square units, right? Now let us see the graphical representation of this integral. So now to see the graphical representation of this integral, let us take the function f of x, right? So f of x is minus x plus 6, right? So now if we take f of x is equal to y, then we can write y is equal to minus x plus 6, right? So here we have a linear function, right? So y is equal to minus x plus 6, and it represents a straight line, right? It represents a straight line. So here if we take minus x to this side, we have x plus y is equal to 6, and we can now write it as in the intercept form, that is x over 6 plus y over 6 is equal to 1, right? So here we have represented this function in the intercept form of the straight line. So we have x over a plus y over b is equal to 1. So the x-intercept is 6, and the y-intercept is also equal to 6, right? So it means this straight line cuts the x-axis at the point 6 comma 0, and the y-axis at the 0 comma 6 point, right? So now here we can take the point 6, and here we can take the point 6, right? So this is a rough diagram. So the straight line x plus y is equal to 6 can be drawn like this, right? Now see, we have to integrate from 0 to half, right? So here this is our lower limit, that is x is equal to 0, and we can take half as the upper limit, and we can take it somewhere here. So this is a rough diagram, so we can take half somewhere here, right? So now we have to integrate from 0 to half, right? So if we go like this, that is if we join this line, that is x plus y is equal to 6, then we'll get this dotted line, right? And now the area is this area, right? So we have to find the area of this shaded region. So now see, this dotted line intersect this straight line x plus y is equal to 6 at this point. Let us take this point as A, right? Now to find the coordinates of this point A, see the x coordinate is half, right? So the y coordinate can be obtained from this equation, that is x plus y is equal to 6, by taking x is equal to half, right? So here we take half, so y is 6 minus half, that is 12 minus 1, and that is 11 over 2, right? So the coordinates of A are half and 11 over 2, right? So now we draw a line that is parallel to the x-axis, right? So now here we can take this point as B, which is 0 comma 6, right? Okay, so now this shaded region it can be divided into two regions. So the first one is this rectangle, and the second one is the triangle. So now for the sake of convenience, we can redraw this shaded region here. So here we have 0, here we have half, right? And see, here we have the point A, here we have the point B, and this point is 0 comma 6, and here we can take this point as C, and the coordinates of this point C are 0 comma 11 over 2, right? So our shaded region is the sum of these two areas, right? So the total area is equal to area of the rectangle and the area of triangle, right? So here we have this rectangle. So the area of this rectangle is length times breadth, and here the area of triangle is half base times height, right? So see, the area of rectangle is equal to length times breadth, so the length is equal to 11 over 2, right? So here we have 11 over 2, and the breadth is half, right? So this is our breadth, so we have half here, and here we have half, and the base of the triangle is CA, right? And CA is obviously equal to half, right? So here we have half, and the height is BC, right? So the height is BC. So BC can be obtained by uh, subtracting 6 and 11 over 2, right? So this is 6 minus 11 over 2. So this is 12 minus 11, that is half, right? So here we have half, right? So now we can add these two quantities. So we have 11 over 4, and here we have 1 over 8, right? So it means the area of this rectangle is 11 over 4, and the area of this rectangle, this triangle, is 1 over 8. So now we can add these two quantities. So the LCM of 4 and 8 is 8. So here we have 4 twos are 8. So 2 11s are 22. And here 8 ones are 8 and 1 ones are 1. So we have 23 over 8, which is same as this area, right? So the value of this integral can be verified by adding the areas of this rectangle and this triangle, right? So viewers, this is a very, very important and conceptual problem for beginners, and this is how we can combine uh, this definite integral with this area, right?